Hey guys, it's time for the next video. I gotta take off my stuff or remember to take off my gloves, but not the other things. Okay, this video is going to cover section 2.3, which is about the limit of a function. It's really in 3 parts, but we're going to do it in 4. We're actually going to review some algebra concepts because otherwise the math behind this can be a little difficult. And then we're going to go into the properties of limits. Then we're going to do a bunch of examples. And then we're going to look real quickly at the squeeze theorem. You ready? Me too. Okay, let's do it. This is not a comprehensive sample, but you definitely have to know how to factor. So let's do it. Let's take a look at this one here. This is a binomial. It has 2 terms. I'm going to factor it using the GCF method. So I can take out a 2 and I can take out an x from both terms. All right. So if I take a 2x out of here, I'm going to end up with x squared. If I take a 2x out of here, I'm going to end up with a negative 16. Well, note that I am not done. That x squared minus 16 is a difference of squares, and that can be factored into x minus 4 and x plus 4. Remember that stuff? Okay, now it's all broken up. Keep in mind, it's not always, but a fun little rule of thumb is this. See how you're starting off here with a power of 3? And then see how we broke this up into 1, 2, 3 linear factors? It's not a coincidence, okay? We basically try to break things up into linear factors or linear and quadratic factors, but things that can't be broken down anymore. Okay, let's look at another one. This one might be a trickster for you guys. This is a difference of cubes. All right, so a difference of cubes is factorable. Oh, sorry, I wrote it on top of the other thing. A difference of cubes is factorable. You just want to make sure that you remember the rules. A sum of cubes is also factorable, so make sure that you know the rules of that as well. Okay, difference of cubes is what we're going to factor. So let's look at that formula. A difference of cubes is like this. If I say I have 2 things that are being cubed, x cubed minus b cubed, that can be factored in the following way. I can factor it into a binomial and then a trinomial. So the binomial is this, because it's a cubed minus b cubed, plane chain a minus plane chain b. Next, my trinomial. It's going to be a squared plus ab plus, squeeze it in there, b squared. This is how a difference of cubes will always factor. Just so you know, if you are factoring a sum of cubes, the only difference will be this. Okay, use the color code. This is this, basically call this like the SOAP idea for the signs. It always goes same, opposite, always positive. Okay, same, opposite, always positive. Anyways, the players are always the same. So I've got x cubed minus 64. This is like saying x cubed minus 4 cubed. Okay, because 64 is 4 to the 3rd power. So this will factor into x minus 4, and then x squared, and it's opposite this sign, plus, and then x times 4, or 4x, and then plus, because the last one's always positive, 4 to the power of 2, which is 16. All right, so this is now completely factored. Again, notice here I've got a power of 3, so to the third power, and then I factor it into a quadratic, which is a power of 2, and a linear, which is a power of 1. 2 plus 1, that's 3. So I've got it broken down correctly. All right, I left an easy one for last. Oh my God, I really need you to know how to factor these bad boys because these are going to come up all over the place. And if you don't know how to do it, this is going to be a rough semester for you. Just put it that way. Okay, if I have to factor a trinomial like this, the rule of thumb is I look at the factors of the last number because there's no number in the front. The number in the front is assumed a 1. So the factors of 10 are 1 and 10, 2 and 5. I'm looking for the factors of 10 that subtract to give me 9. And so that is going to be, it's a negative 9, x minus 10 times x plus 1. Okay? And then that's how I factor that last one. Again, this is not a comprehensive list. This is definitely just a small sampling of factoring problems. And you got to make sure that you can factor because otherwise this unit's going to be a real bear. Okay, besides factoring, we also want to know how to expand. So let's look at the next example. Okay, for our next examples, we're going to expand some functions, which basically means multiplying them out. This does lead to the side topic of Pascal's triangle. So I'm actually going to talk about that first. But while I'm writing out Pascal's triangle, I want you to multiply this out. Let's test your instincts again. In fact, I want you to see if you can do A and B. If I finish Pascal's triangle before you finish A and B, just pause it and see if you can get the correct answer. On your mark, get set, expand. Okay, how'd you do? All right, I'll talk about this bad boy in a second. Let's take a look at letter A. Okay, so x plus 4 squared. If you are going to square x plus 4, here's the deal. Many students remember this part, the x squared and the 16. But do you remember the middle part? Did ya? Okay, remember, if you ever square a binomial, you're going to end up with a trinomial, okay? If you don't believe me, FOIL it out. But the idea is that if you have a binomial and you're going to square it, you're going to get the first value squared. So x times x is x squared. Then you're going to have to do 4 times x times 2 because you have double. Okay, so that's going to give you 8x. And then 4 times 4 is going to give you 16. That's going to be that. All right, now, for this one, if you were doing this one the long way, not the Pascal's triangle way, understand what you would do is you would first think of it like this. Think of it as x plus 4 times what you got over here, x plus 4 squared. So you'd use the results from the previous problem. And then just distribute the x out and distribute the 4 out and combine your like terms and you get your answer. So I'm just going to hit a little ... for that. All right, but the other way that we can do it is by using Pascal's triangle. Okay, Pascal's triangle is a pretty neat little thing. It's a neat little trick, especially if you have to square stuff, cube stuff, put it to the 4th power, especially if you're in calculus, you get to use it a lot. So the way that Pascal's triangle starts is this. You have 1 and then 1, 2, 1. Those first two rows you just have to memorize. And just think of it as a little triangle, okay? And just think of it, you know, just set up 1 and then 1, 2, 1. The next thing is this. The next row is set up as follows. When you go to the next row, you always extend the row by 1. And then to find the numbers in between, you add, okay? You add these values to get 3. So 2 and 1 get 3. Notice again, so go to the next row, all right? Now I have 1 and 1, and then I use the previous row. So here I've got 1 and 3 gives me 4, 3 and 3 gives me 6, 3 and 1 gives me 4. Okay, so remember, just do this again. Look at that fourth row. For the fourth row, the first thing I do is I put the 1s out. Then I take the previous row and I say 1 and 3 gives me 4. 3 and 3 gives me 6. 3 and 1 gives me 4. And that's what fills out in between the 1s. Let's see if that makes sense for this last row here, because I only did 5 of them. So let's go to the last one. Notice I put my 1s outside, and then let's add from the previous row. So here I've got 1 and 4 gives me 5. 4 and 6 gives me 10. 6 and 4 gives me 10. 4 and 1 gives me 5. Well, try it a couple times, see if it gets a little bit easier. It's just expanding by 1s, adding the middles. Expanding by 1s, adding the middles every single time. And this thing can go on forever and ever and ever, amen, until you're done adding and expanding. Well, the whole joy of Pascal's triangle is this. If you are taking a binomial to a higher power, you can use Pascal's triangle to help you get there. So, for example, this row refers to a plus b squared, a binomial to the second power, okay? And these are the coefficients. You'd have 1, 2, 1. And notice how we have 1x squared, and then we doubled that middle term here for 4. 4 times 2 gave me 8. And then that last one was 4 times 4 times 1, which gave you 16. This is always true. So if I'm going to use Pascal's triangle to take the third power, this is what I'm going to do. I'm going to use that third row. So let me just write that out. So I've got 1, 3, 3, and 1. All right, those are the coefficients. The next thing I'm going to do is I'm going to look at what I'm putting to the third power. Okay. The first thing is x. So I'm going to start with x to the third power, then x to the 2, x to the 1, and x to the 0. Notice the first one, the x, starts high and then goes down. The next one, the next thing I have, because I'm going to cube x plus 4, is I take the 4. And instead of starting the 4 over here, I'm going to start the 4 over here at the highest power. So I'm going to have 4 to the 3, 4 to the 2, 4 to the 1, and 4 to the 0. And then I'm going to combine these to get the answer to x plus 4 to the third power. So let's multiply these together. 1, so I've got 1 times x to the 3 times 4 to the 0, which is 1. And that is going to give me, and I'm going to put the, actually, yeah, I can fit it down here. That's going to give me x cubed. For my next term, that's this thing right here. For my next term, I'm going to take 3 times x squared times 4 to the 1. So that'll give me 12 x squared. And then I'm going to add the products in the next column. So 3 times x to the 1 times 4 to the 2. That's 16, right, times 3. What is 16 times 3? 40. 48. So 48, x to the first power. That's from this third column. And then this last one here, I'm going to add to it 1 times x to the 0 is 1 times 4 to the third, which is 64. And that's how you expand x plus 4 cubed. We've got more. Oops, I somehow backed out of it. Okay, so let's see if you're up to the challenge. We're going to take x plus 4, we're going to put it to the 4th power. So remember, Pascal's triangle stands for any binomial being put to a power. So it's the 1, 2, 3, 4th row that we're going to use to take this binomial to the 4th power. So what I'm going to do is first I'm going to write the Pascal's triangle numbers for that row down. Oh, except for I skipped one. I'm going to write the right ones down. 1, 4, 6, 4, and 1. Now what I'm going to do is I'm going to look at what I'm cubing. So in my binomial, I'm starting off with the x. So since that's the first one, it's going to start big. So the power is 4. X to the 4. X to the 3. X to the 2. X to the 1. X to the 0. Next, I'm going to start with the second guy in the binomial. I'm going to start with that h. Now, you can either start with the h at h of 0 or start with the h up here, h to the 4, and then count backwards. It's up to you. And now what we're going to do is we're going to put it together. Okay, so this first column is the first term of this answer. Okay, so I'm going to have 1 times x to the 4 times h to the 0. So that's going to give me x to the 4 for that first column. Then I'm going to add when I multiply in the second column. 4 times x to the 3 times h is going to give me 4x cubed h. And that's for that second column. I'm going to add to that what I have here in the third column. I'm going to cough first, though. I don't have the Rona. It's allergies. I'm allergic to the library. Sorry, it's kind of a joke, but it also kind of isn't. This is an old building. Okay. So for my third column, I'm going to have 6 times x squared times h. So that's going to give me 6 times x squared times, h squared for the third column. The third column gives me my third term. Now I'm going to take my fourth column. I'm going to add to that 4 times x to the 1 times h to the 3. So 4 x to the 1, h to the 3. And then my last column, I'm going to add that 1 times x to the 0, which is 1 times x to the 4. Sorry, h to the 4. And when I'm done, that's what I'm going to have. So x plus h to the 4th power is equal to this long polynomial. Okay, for this next problem, I needed to give myself a little bit room, but I've got x plus h to the 5th power. And so again, I'm going to use my 5th row of Pascal's triangle in order to multiply this out. So I'm going to write down the numbers from the 5th row of Pascal's triangle for letter D here. I need some space though, so I'm gonna move over a little bit. So 1, 5, 10, 10, 5, and 1. So remember, I'm starting off with x first. So I'm going to have x to the 5th, to the 4th, to the 3rd, squared, 1st, and 0. Then I've got h. You can either start at 0 and count up, or you can start high and count down. The only reason why I show students to count down all the time instead of counting up is because often students don't remember to, if you are to count up, they forget to start at h equals 0. So fill them in that way. Now, you ready? Okay, this is going to be my first column, and that's going to give me my first term. So 1 times x to the 5 times h to the 0 is x to the 5. And I'm going to add to that what I multiply here in the second column. So 5 times x to the 4 times h to the 1. And I'm going to add to that the third column. So 10 times x to the third times h squared. And then I'm going to add to that the next column. 10 times x squared times h to the third. Oh, I'm going to run out of room. These are long. Then I've got the next column. I'm going to add to that 5x and h to the 4. We're going to curve up here. And then my last column, which is going to be h to the 5th. All right, sorry I had to curve up. The marker liked that problem. Screaming's a good thing. Now, again, Pascal's triangle is just a shortcut. You are more than welcome. If you want to do x plus 5th or x plus h to the 5th power the long way, you can. Okay, just square it a couple times, square it twice, and then multiply those together. That'll give you x to the 4th, and then take that x plus 5 or x plus h and one more time, and then you'll have it. Or, right? You can do this in 5 minutes. You can do it the long way in about 10, maybe 15. It's a long time. It'll take a long time. But you just want to make sure you're coming up with the same answer. Okay. We are going to use this coming up, so make sure that if you got lost at all with what I was explaining, that you rewind it and watch it again. All right, catch up with me in a second, and we'll talk about properties. Next, we're going to look at the properties of limits. And this is way too small. You can't see all this. I'm going to have to fix it. This is in your textbook, so you can find it in section 2.3 under the properties of limits. But I'll be right back. Let's make it bigger. There we go. Now, I want you to know something. You don't have to have these memorized. You do have to be able to use them, though. And what that means is that you just want to know, when is it okay for you to take a limit in a function? If you have a big function, how are you going to find the limit of it? Okay, so make sure that you just have a functional knowledge of all of these rules. Basically, the idea is that you can add and subtract limits. You can pull a constant out of a limit. You can multiply limits. You can divide limits as long as the denominator is not equal to 0. You can also take limits to a power. If you have a constant, the limit of a constant is just that constant. If you have the limit of just a single variable, then the limit is equal to that limit, okay, that limit approaching. If you have, a, which is your constant, and n is your positive integer, this works for powers, it works for radicals, and it works for roots as well, okay? So again, these are in your book. Don't have to have them memorized, but you do have to have a functional knowledge. If you need to, pause this video or look it up in your book so you can write these down. Okay, we've come to the second part of this section. We are going to do a ton of examples. Just bear with me. If you get stuck at any moment, of course, go ahead and rewind. Just so you know, when you're doing a limit, this is the thing that you typically want to do, okay? First thing, always take that value and plug in A. So whatever your limit value is, which in this case is 3, first thing you want to do is you always want to plug it in. See what happens. If it just comes out with a number, that's good. plug it in again, make sure you didn't make a mistake, and go ahead and use that. Next, what you want to do is I always go for, just to check your answer, look at a table of values. When x approaches a from the left and when x approaches a from the right. Okay? I just go into my calculator, I put the equation in. If the first thing doesn't work, I go to my calculator, I put the equation in, I plug in values that are very close to it that are smaller than that. I plug values that are very close to it and larger than that, and I look to see, okay, what's my final answer going to be? And then I just call this last part, which is math magic. Okay, math magic, you do so many things with the math magic or math smoke and mirrors to find something algebraically that will match what you found for number 2. Now again, if it's a straight plug-in, you don't have to do anything. Okay, if you can plug it in and it doesn't make the function crap out or say error or anything like that, you stop with step number 1. You plug it in, it works, you're good. But if the number 1 doesn't work, if you get an error, look at the table and then do math magic to get an answer that matches what you have in your table. Or you can do the math magic first, it's up to you, and then check your answer at the table. But either way, you want to make sure you do both. Now, math magic, math smoke and mirrors. What do I mean by that? Well, there's a bunch of stuff, okay? You may need to factor. You may need to expand. You may need to add fractions, so, find the LCD and not add the LCD, but add using the LCD. You may need to do something funky like multiply by the conjugate. Okay. There's a couple things. Oh, you may also maybe need to multiply by your LCD. It depends. It depends on what you got going on. All right, so let's look at this first problem. So first things first, let's plug in 3 and see what we get. So the first thing I'm going to do is I'm going to take, I'm actually going to do it over here. That's not lined up. It's so hard to tell where things are on this board. I'll get over it. Next decade. Okay. I'm going to plug that in. So I've got the cube root of, so x to the 4 means 3 to the 4th minus 7 times 3 plus 4, and then I'm going to square it. So 3 to the 4, 2, 3, 81 minus 21 plus 4. I don't know what that is. And then I'm going to square it. So I'm going to do all this, and then I'm going to square it, and then I'm going to take it, the cube root of it, and I did this previously, and it didn't error out. I ended up getting 6. So the limit of this function is equal to 6. Make sure to always plug it in, because otherwise you're going to do a bunch of work for nothing. Okay, this second one here. Let's work on that one. I'm going to come over here. Oops. So I want you to note, if you plug it in first, you end up with 4 squared minus 4 times 4, which gives me 0 on the top. And then for the denominator, I'm going to end up with 16 minus 12, which is 4, minus 4, which is 0. All right, I got 0 over 0. When I'm trying to find limits, that actually means I need to go right to my math magic. I definitely can plug in my table of values to see what my answer is going to be, but I know I need to do some math magic to find something. So this is what I'm going to do. All right, let's do it then. Now, before each step of math magic, make sure that you are writing your limit statements. So the first thing I'm going to do, because I've got a rational function and I got the 0 over 0, which will come up again, by the way. But at this stage in the game, when I got a 0 over 0 and I'm trying to find a limit, I'm going to factor it. See if I can factor something. See if I can get that to work. So my numerator, I can factor out an x. For my denominator, I can factor this into x minus 4 and x plus 1. Again, just think about this. I've got 4. What factors of 4 subtract to give me negative 3? So it's a negative 4 plus 1. And then notice what happens. This bad boy cancels. And that's very exciting because it's that x minus 4 in the denominator that's causing problems with x as it approaches 4. So now I'm going to plug in the 4 again. So I'm going to have 4 in the numerator, and in the denominator, 4 plus 1, which gives me 5. And so the limit as x approaches 4 for this function is going to give me 4/5. Now, don't take my word for it. Sometimes I tell lies, not on purpose, but it just happens, right? A sign error, fraction error, something. But this is a little bit unique because I'm recording myself. Then there's no students to say, yo, hey, professor, what happened there? Isn't that supposed to be positive? Isn't that supposed to be 3? Isn't that supposed to be 2? So here's the deal. Never trust me. You should always check it yourself. And let's talk about that check. Let's talk about this step 2 here, plugging into the table of values. So I don't have the capability at this moment to put my calculator up here. I haven't figured that part out yet. But I do want to talk to you about it. So the first thing you're going to do is you're going to go to your calculator, and in your y1, you're going to put the original function, okay, and use parentheses. Otherwise, your calculator won't know what function you're trying to plug in there. So you're going to put that into your calculator. Then what you're going to do is you're going to go over to your table. Now remember, you are looking at the limit as x approaches 4. So that means you want to go to values very much smaller than 4 and then bigger than 4. Okay, so I'm going to look, so smaller than 4 is 3.9. And then I'm going to type in 3.99. And then 3.999. And then 3.99999. You get the point. Okay? And then I'm going to do the same thing from the other side of 4. I'm going to approach 4 from the larger side. I'm going to plug in 4.1, 4.01, 4.001, 4.0001, 4.01. And then plug that in and see if you can get your answer to match 4/5. All right, what is 4/5? 0.8? Yeah, you should get 0.8. What you'll do is you'll get like 0.8000001 and 7.99999 or 0.7999999, but you'll get something that is close to 0.8. And that's the goal. You want to make sure that your table matches your results from your math smoke and mirrors. Next couple of examples. I've got h approaching 0. So I'm trying to find the limit as h approaches 0 of negative 5 plus h to the power of 2 minus 25 equals h. All right, so if I plug in the 0 first, because that's the first thing I want to do, I'm going to end up with negative 5 plus 0, which gives me negative 5. Square that gives me 25. I get 25 minus 25, which gives me on the top 0. So I'm just going to do 0. And then when I plug in 0 here, I'm going to get 0. Darn it, you can't see that. I'm going to get 0 over 0. Can you see that? Shoot, you can almost see it. Okay, so plugging it in didn't work. It gave me 0 over 0. Before I was like, ooh, do some factoring, but let me tell you right now, I actually Do I want to do factoring? Okay, so I can, but I also can do some expanding instead. It's up to you. It's up to you. Creative freedom here. You guys ready for this? Okay. Remember, before each step, let me come up here actually. I'm going to do, I'll write that over here. Okay, so I'm going to write the limit as h approaches 0. Now, this may seem a little strange, but what I'm going to do is I'm going to factor it first. I'm going to treat this like a difference of squares. Remember a difference of squares. Can I reach up here above examples? Yeah, remember a difference of squares. Like what if I had u squared minus 25? That thing would factor into u plus 5 and u minus 5. So that's what I'm going to do here, only I'm going to treat u like that first binomial. So I'm going to take this, I'm going to factor into minus 5 plus h plus 5. I'm going to factor it into that. And then I'm going to factor it into minus 5 plus h minus 5. Sorry for the squeaking. And then I'm going to leave this at h. Oh, I hope this works. I don't know. Maybe it's a bad idea. Okay, so I'm going to end up with negative 5 and 5 gives me 0. So this one here gives me h. So I end up with h. And then here I've got negative 5 and negative 5 give me negative 10. So I'm going to have negative 10 plus h. And that's all over h. Ooh, that was a good idea. By the way, if you ever try something and it doesn't work, like I tried factoring, I would then go to expand. I would try something else. If you do one thing and it doesn't work, you try something else in your math tool belt. So why was I excited? Why did I know that was going to work? Well, I could see this. My h's were going to cancel. So now I have the limit as h approaches 0 of negative 10 plus h. Well, now I can just plug it in. So I plug in 0 for h, and I'm just going to have negative 10 plus 0, which is going to give me negative 10. Okay. If I had expanded it, let me see if I can squeeze it in here. If I had expanded that, I actually would have rewrote it first as h minus 5. So just so you know, I would have taken this guy right here. I would have written it as h minus 5 squared, and then I would have expanded it, and I would have gotten that. Okay, I would have gotten h squared minus 10h plus 25. And then I would have remembered that minus 25 on the end of it, and then over h. Notice what happens for that is the 25s cancel, plus 25 minus 25, poof, disappear. And then I've got h squared minus 10h all over h. And then again, I'm in a position to cancel some things, and I get excited. You want to be careful. Don't cancel willy-nilly. You got an h down here. You can only cancel this h down here if everybody in the top has an h as well, which they do. So you can cancel it. Okay, so you're going to end up with h minus 10 once the h's cancel. And then again, we plug in the 0, and we get negative 10. Notice, regardless of what math smoke and mirrors we use, we end up with the same limit answer. Just in case either of those were confusing, remember you can always pause, rewind, and rewatch. Okay, let's take a look at this next one. First things first, let's plug it in. I'm going to have 1 plus 3. That gives me 4. Square root of 4 minus 2 gives me 0. And then plug in the 1 minus 1, that's going to give me 0 over 0 as well. So I know that that first one won't work. So I need to try something else. I'll tell you a secret when it comes to these radicals. Often what I want to do is I want to multiply top and bottom. either by the conjugate or by the radical that's causing a problem. And in this particular case, what I'm going to do is multiply by the conjugate. Which conjugate am I going to multiply, though, by? I didn't say that right. By which conjugate am I going to multiply? Right? I could multiply by the conjugate of the denominator, which would be, I could multiply both sides of the top and bottom by x plus 1. But I'll tell you right now, that's not going to help. It's not going to cancel anything. No, it'll be unsuccessful math magic. Okay? So what I'm going to do is I'm going to multiply by the conjugate of the top. So since the top is the square root of x plus 3 minus 2, I'm going to multiply this function by the conjugate, which is the square root of x plus 3 plus 2. And because I need to do legal math moves, I don't want anything to be illegal when I do my math smoke and mirrors. I have to multiply top and bottom by this. Okay, what am I going to get? I want you to pause it for a second. I want you to multiply the numerator and the denominator and tell me what you're going to get. I'll give you a hint. Sorry about that. Your denominator is going to look like this. Okay? Your denominator is going to look like this. In other words, when you multiply your denominator, nothing magical is really going to happen yet. It's just this binomial times this icky binomial. But what about for your numerator? You're going to be multiplying this value right here, sorry. Where am I? You're going to take this x plus 3, the square root minus 2, and multiply that by x plus 3, the square root plus 2. And what are you going to get? Your mark, set, multiply. See if you can match me. Pause it. Just in case you didn't pause, I will always wait a little bit, give you the real classroom experience. Okay. When I multiply conjugates, what I end up with is a difference of squares. Keep in mind, that's what a difference of squares is up here. You got x plus 5 times x minus 5, or sorry, u plus 5 times u minus 5. You end up with u squared minus 25. So that's what I'm going to end up with here. I'm going to end up with x plus 3, the square root squared, minus 2 squared. And what that actually ends up giving me, if I square the square root, that's going to give me x plus 3 and then the minus 4 goes along for the ride. As I'm writing it down, do you see it yet? Do you see it? Do you see it? Do you see it? Do you see the exciting thing that happens? Yeah, if I've got x plus 3 minus 4, x plus 3 minus 4 turns into what? Yeah, x minus 1. So if I were to simplify this thing right here cancels with this thing right there. And then I've got the limit as x approaches 1 of 1 over the root of x plus 3 plus 2. Okay, now that I got something to cancel, I want to plug it in again, see if it works. So in the numerator, I've got 1. In the denominator, I've got 1 plus 3, the square root of, so that's the square root of 4, plus 2. Well, square root of 4 is 2. So 2 plus 2 is 4. So for that limit, I end up with an answer of 1/4. Once again, don't take my word for it. Plug in values that are very, very close to 1. Okay, what's close to 1? 0.9, 0.99, 0.999, 0.999, and 999. And then 1.1, 1.01, 1.001, 1.0000001. 0, I didn't talk about it for this one, but if you need to plug something in for 0 to check my other one with -10, plug in values that are very close to 0. 0 is a little unique because it's in between negatives and positives. So what it's going to be like this. You're going to plug in 0.1, 0.01, 0.001, 0.001. And then on this side, you're going to plug in negative 0.1, negative 0.001, negative 0.1, negative 0.01, negative 0.001, negative 0.0001, so on and so forth. Okay? All right. Yeah, we got a few more examples to do. Let's do them. The next ones I put on the board, I want you to see if you can do them first. Give each one of them a try first, and then see if we can get the same answer.